Hello everyone. In this lecture, we are going to demonstrate how to use Inventor to perform kinematic analysis. And we'll use this 6-bar mechanism to demo. So you can see how this mechanism is going to operate. Basically we'll use this one as the input. And you're moving this way. It's a 1 degree of freedom mechanism. Okay, so before we go into the kinematic analysis, I'm going to show you how to assemble this mechanism first. So let's open a new file, new assembly, and we will place those links into the space. So there are 6 links here, those with the file name .ipt are the links file. So I'll start with the base. We usually start with the base because the base is a reference for all the other links. So it's better you start with the base. So you choose a base and just select a proper position. Right now it actually doesn't matter where you select the position. So once you select the position, then you click your mouse, then the link will be placed. And then once you place this base link, the very first thing you need to do is to fix it. So you right click the base link on this tree list and go into grounded. This will make these links not movable. So when you try to drag it, it is not going to move. If you didn't ground it, then once you drag it, it will just move. But we want a base link to be fixed. So you will ground it first. And then we will place our second link. Let me change the view. Okay, so the second link I'm going to place is the arm. So I'll put the arm into the space, just randomly assign a position, and it's going to let you place another link. Then you just press escape on your keyboard because we need only one link for now. Then once you put this link into the space, then it's freely moved around the space. Then what we need to do is we want to make an arc joint between this link, this purple link, and the brown link. So we'll choose joint to connect these two links. When you click joint, it will say place joint, and so you will need to choose where you are going to put the joint, and you also choose the type of the joint. In this case, because we know the joint is rotational joint, so we will just choose rotational type, and you select this circle and to match this circle. Then once you select both of them, it will just automatically move to this location and finish this joint. So you can click OK to finish the first step, the first connection. And here, if you drag this link, now is constrained by this arc joint. So we can move to our next step. So you place another link. Here we're going to place arm 1. So you place this arm 1 here, and we try to connect these two together. So again, this one is an arc joint, so we go into joint, select rotational, and I want to match this surface with this surface. So I'll select this blue one first, and then select this purple one. So once it's done, you can click yes, and yes, this joint is finished. And just take a look. The next one we are going to place is this one, this light blue link. So I go back to my assembly, and I'm going to place that link. I name that one as slider L. So you place this link into the space. So here we need to connect these two blue links by another R-joint. So again, you select joint and rotational. You select this one, and then this one. So these four links are connected, but we need to assign another joint because we know this light blue one must be sliding on this brown surface. Okay, you know, if you want to rotate this mechanism, you can press the shift key on your keyboard and then press the middle button of your mouse. Then you can rotate this link, rotate this mechanism. Yeah. And if you want to do the pen move like this, you just press the middle button of your mouse. Yeah. If you want to zoom in or zoom out, you can just scroll your the mouse. Okay, so the next joint I'm going to place is a joint that allow this blue one sliding on this brown one. There are two options here. You can either use slider or use planar. Because it's a 3D mechanism, so I would prefer to use planar, yeah, in order not to over-constrain the mechanism. So I choose planar, and then I'm going to choose this surface. It's going to be in contact with this surface. It will just randomly move, but no worry. Once you finish the selection, then click OK. The slider will just be attached. Then right now, if you rotate this mechanism, yeah, it's going to move properly. So the next one I'm going to place, let's take a look of this assembly, is this green one. It's placed in this orientation. So back to our assembly, I call this oscillator. So you place this oscillator into the space, but now because we want this pin on the other side, so you need to rotate this link by 180 degrees to make it face to the other side. So we'll use the option here called free rotate. So you click free rotate and click this link. It will show you an option to rotate this link. So you click your mouse, the right button of your mouse, to rotate this single link. And I think it's approximately the position we want. Then you just press escape on your keyboard to finish the rotation. Then here we need to make another R joint to connect the light blue one and the green one. So I choose this joint, and again we select rotational, and I choose this surface to be attached with this surface. So it's done. Yeah. And the last one we are going to place is a small slider. So the slider, I'm going to place it here. And this small slider is connected to the green one with the R joint. So again, we assign an R joint, rotational joint, between these two. So the last step is to allow the slider sliding on this surface. So I'm going to make another joint, another planar joint, to attach this surface to this surface. Then once it's done, you can click OK. Then the assembly is done. So now you can move this input link, then you will move as what we desired.